So this is another short lecture, short explanation video to discuss a problem I gave you for the test. Here this was the problem, and yeah, you have a machine shown here which is used for moving heavy items such as pallets or bricks around construction sites. So for the horizontal boom position shown, you are asked to determine the force in each of the two hydraulic cylinders AB. So there are two hydraulic cylinders AB here. So the one is on the other side. So all you need to do is consider it as a single consider it as a single hydraulic cylinder. Find out the force in AB and divide it into half. So that will make it two cylinders. We will simply assume that the force is equally distributed to both of the cylinders. So mass of the boom is 1500 kilogram with the mass center at G1, and the mass of the cube of bricks is 200 kilogram with the mass center at G2. So there are two mass centers which has a certain mass, and this combined weight causes a force in the member AB, and we need to calculate it. So this is actually this is not difficult at all. So all you need to do here is you need to draw the free body diagram of individual members. Use the equilibrium equations, and there you have the answer. The positions of each members are clearly defined. And let's try to draw the free body diagram of the horizontal arm here. So you have you have, first let's draw the points here. You have O here, about which the whole arm rotates. Then you have B here, a little bit above O, and that distance is given to be 150 mm. And you have G1 and G2. The vertical distance of G1 and G2 from position O is given here, but you can see that the vertical distance of G2 from any of the reference point is not given, and that is not required also. So let's say that we have G1 here and G2 here, and this is the member, and it does not really matter what the shape of the member here is. It does not matter at all. I can even show a completely arbitrary shape here, but the only thing I need to take care here is I need to make sure that while doing the calculation, point B is 150 mm above from O, and then I need to correctly take the horizontal distances. This distance here is 600 from O to B, and from B to A. So there is an arm. So this is another member. I'm just showing here so that we can mark all the dimension here, and then you have distance from here to here, which is 740. Distance from here to here, which is 740, and from distance from here to here, that is from A to G1 is 1700, and from this is G1 and this is G2, this is A and this is B, right? And from G1 to G2 you have 3060. So all this horizontal distance are the only thing that you need to take care of here. So at this point you have a weight W1 and you have weight W2 here. So masses are given here. These masses can be converted to weights with proper units. Now another important distance here is the distance between O and A. O and A. So from B to O it's 150, and from O to A it's 890, right? Now from a single equation you can find out the member force in AB, and this there are two pistons. So once you calculate member force in AB, you just divide it into 2 and you get the answer. This is very simple and straightforward. Take moment about O. Net moment about O is 0, and from this equation you have straight away the answer. So I am considering O here. So with respect to O, so there is this member force from AB. So I can split into two. I can split it into two parts, one vertical and one horizontal. So this is the member force which we need to calculate, AB, FAB. This is the to take a single equation here you will probably need this angle also, so that also you need to calculate. Otherwise it will be a problem. It won't be a problem, but I think the easiest way will be to calculate this theta here, and that theta is given here because this distance you already know, that is 890 plus 150. Distance from A to B is, the vertical distance from A to B is 890 plus 150, and distance from here to here is 740. So tan theta will be equal to this divided by this, and theta will be equal to tan inverse that quantity. So you have theta. So once you have theta, then you can write FAB cos theta here, and FAB sine theta here. So two external forces drawn, and there are going to be many external forces on so here I am going to this moment equation is taken with respect to this whole arm, okay, the whole arm. So the external force from AB on the arm is split into two parts, FAB cos theta and FAB sin theta, and theta is already calculated, and there are many forces, not many forces, there is a force on arbitrary direction with a certain magnitude on O, but we don't need to worry about it because we are taking moment about O, and if a force is passing through O, then the perpendicular distance between line of action of that force and the point O is 0. So that term will disappear, and that will not be there in the equation. And other forces are only two weights, nothing else. So here you have a weight W1 acting and another weight W2 acting here. So these are the external forces on the arm here. So from this support, some force about which we don't care because it's passing through O and we are taking moment about O, so that we don't need to worry about. And force from the arm AB on the force from the piston AB on the arm, the horizontal arm, is split into two parts, FAB cos theta and FAB sin theta, in which theta is already calculated, and then you have W1 and W2, which is all known. Now you can write down the equation. So R into 0 gone, FAB cos theta multiplied by FAB cos theta multiplied by distance between line of action of FAB. This is the line of action of FAB cos theta. Distance between line of action of FAB cos theta and the point O is given, that is 890 plus 150. So multiplied with that, and that causes a clockwise moment, so that will be negative. Then you have FAB sin theta. So this is the line of action of FAB sin theta. So this is the vertical, this is the perpendicular distance between line of action of FAB cos theta and point O, and that is 740 plus 600. 740 plus 600. That is the perpendicular distance between line of action of FAB sin theta and the point O, multiplied with it, and that is causing about O, it's causing an anti-clockwise moment, so that's positive. Then you have a moment due to W1, and that's this is the line of action of W1. The perpendicular distance between line of action of W1 and the point O is 1700 plus 740 plus 600. So that is the perpendicular distance between line of action of W1 and the point O. So W1 multiplied by that quantity everywhere, and that quantity is, that moment is clockwise moment about O, so that is negative. And then you have W2 multiplied by perpendicular distance between line of action of W2 and the point O, and that is this is the line of action of W2. Perpendicular distance between line of action of W2 and the point O is 3060 plus 1700 plus 740 plus 600. So this multiplied by that quantity, that is again causing an clockwise moment, so negative. So sum of all these should be 0. So here almost everything is known. W1 is known, W2 is known, all these distances are known, theta is known, so sin theta is known, cos theta is known. Only unknown quantity is FAB. So you can calculate FAB. So FAB is the combined load bearing capacity, not load bearing capacity, the combined load taken by 2 arms of FAB. Here they are saying that there are 2 arms, so divide your answer into half, you will get the force in 1 amp. So that's it. I think now you can solve the problem.